Now we can talk about these titles. This is the today's lecture titles. Okay, what is machine learning? Types of machine learning. We're going to touch what data is again as a reminder. And also I'll talk about some Python libraries that I'm going to use, right? As you can expect, we'll be using the Python language for this course. And you, as computer programming students, you already noticed, I believe, that Python is one of the most powerful programming, third generation programming languages nowadays. And keeps evolving. And also it has so many libraries in Python, machine learning. So we'll talk about them a little at the end of this lecture. So what is machine learning? Let's start with that. Actually, machine learning is very commonly confused with the artificial intelligence. Or when we say artificial intelligence, people think that it is machine learning. In fact, machine learning is a subfield, we can say, of artificial intelligence field. It's a subfield. There are some other fields in the artificial intelligence which are not supposed to be counted as machine learning. And maybe we can count robotics in it, because although it may be using the software part, the logic part, maybe using the machine learning techniques or such, it also involves in the electronics or mechatronics depth heavily, right? And also cybernetics or this type of different disciplines, it requires robotics, for instance. So electronics and mechatronics is very important on that. On the other hand, when we talk about machine learning, we're not looking at the electronics to be implemented or applied for those machine learning software or applications or projects, or we may count natural language processing as another subfield, which is a little bit, I mean, it has a little bit similarities with machine learning approach, but it's a different field of artificial intelligence, natural language processing, voice recognition, this type of things. So machine learning is a different thing, although it resides in the artificial intelligence, let's say, ecosystem. It's a different thing, part of artificial intelligence, of course. The emergence of artificial intelligence goes back to 80s or maybe earlier, maybe even 50s, we can say, because there is some Turing machine or Turing machine type of, or automata theory or this type of things first delivered or started to be discussed in late 50s, 60s, then in 70s, by the evolution of computer technologies, it gained more power, more familiarity. Also in 80s, for instance, I can tell you that Japanese government made a political decision to invest on artificial intelligence field in 80s, at the beginning of 80s. As a nation, as a political strategic decision, they decided to invest in artificial intelligence area in 1980. But it was too early. It was too early because the hardware capabilities were not that developed already. Okay, So then somehow we can say that that political decision failed at the time. On the other hand, for instance, Indian government decided to invest in software technologies in general, not artificial intelligence, but software technologies. And the software tools and hardware infrastructure was ready or good enough for that. And this is why you can meet or encounter many Indian software engineers or software scientists, computer scientists in the field. What I'm trying to say is this is not a totally new concept. It started in early 60s maybe, but later on, by the emergence of internet in 90s, and when the internet get common and in use all around the world, data started to be accumulated, okay? And also, there was a huge data getting accumulated. On the other hand, it requires the hardware capabilities for processing such a huge data, and also techniques, of course, because it is not possible to deal with such large amounts of data in traditional data manipulation techniques. It requires some other extra different techniques or algorithms, you can say. And then that area called big data emerged. That means that with the emergence of internet and also the increases in hardware performances, opened the doors for artificial intelligence and especially machine learning technologies to evolve, right? By the capability of processing such a huge amount of data, gave us the opportunity to deduce some data, some information from that data, accumulated data. Okay, and also the people and nations who realized this opportunity and the importance of this processing and producing information from that amount of data, pioneered the area. See, for instance, think about that. Facebook. What was the name of that guy? Zuckerberg or whatever it is. Is it Zuckerberg or something like that? I don't remember the exact name.
Zuckerberg, sir.
Zuckerberg, whatever. That guy, that company, Facebook, bought WhatsApp for an incredible amount of money. They invested enormous money. I don't remember exactly, but it was something like $19 billion or something. They paid that amount of money and bought WhatsApp. And if you think that WhatsApp is not a commercial tool, it's free, right? We can use it free. It is delivered with along with our cell phones, and we can use them without paying any money, right? Just for messaging, etc. You should think about it. Why they gave or sacrificed that amount of money as $19 billion, which was the hugest, the largest monetary number paid in IT business up until that time. Okay, so what was the reason behind it? That's Zuckerberg or whatever that guy's name is. They realized that the data that they are able to collect through WhatsApp or such technologies or such tools is the most important thing. Okay, They realized the importance of data. And again, collecting data or having such a data is not enough. You should have the sufficient hardware resources for that. Also, it triggered the hardware companies to work on hardware technologies further. They also invested in that area. And, today, I believe, what is the most valuable company in the world? Do you know? It was Apple in the past, and then Google, Microsoft, all these companies. But what is the most valuable company in the world today? Do you know that?
NVIDIA, sir.
Yes, absolutely. NVIDIA. Why? Because it provides you the hardware capability of processing all a huge amount of data. Okay. And at the same time, of course, when we reach that capability or ability of processing such data, people started, researchers started work on developing some new methods. And that advances or instances, let's say, caused the machine learning field to improve and uh, gain some increased popularity and attention. Nowadays, as you know, we are living in an AI surrounded world. Well, AI surrounded world is something, but AI governed world is something else. I mean, it will be in the future, right? So that fact also triggers some other fields which are not directly related to technology or electronics or whatever, computers, etc., to work on that reality, such as the people in legal business, legislation, etc. They started thinking about the ethical or such concerns about the ownership of the intellectual, let's say, work, right? Who is the owner of that intellectual work? Let's say that you have your chatbot to write some article and uh, just publish it. Well, what is the ownership of that, or I don't know, what is the ownership of that article or intellectual work, or how we should describe it, or if you deliver some incorrect information, who is responsible for that? Can you take the chatbot or any artificial intelligence technology behind it responsible for it? So we need to think about the liabilities, everything. Also, some privacy issues, although they emerged or started to be concerned during the internet revolution. The privacy thing is another thing because, we were just concerning about exposing our personal data on internet or such, but now we are concerned about not our personal data, but as a whole, our interests, our abilities, our questions, everything, uh, as a kind of fuel, because it provides data. So the data is the fuel of artificial intelligence, especially machine learning, right? It is the fuel. So what are the rights? They have the right to process my data. What kind of data we are talking about? It can be anything. Even they can follow your eye movements during you read some text on screen, right? They can follow it, and they can keep track of the amount of time you stay at a certain region of the screen, which, let's say, may have some guy's picture, and they maybe try to measure or understand your emotional responses for that guy, that said institute or government or whatever. So they collect any type of data, any type of data, purposive or not. I mean, they may have some specific purpose in mind or not. They just collect, and then later on, uh, either they start thinking of, if I have such a data, what kind of information can I derive from that data, or to understand some specific thing, or predict some specific behavioral attitude for something. It can be commercial, even political, whatever. What kind of data can I use? If they've collected it in advance, then they can start using it. So all these privacy rights and everything uh, become, I mean, some issues. They all started with such issues. We discussed all these issues, and they realized that we need some regulations for all of these stuff, right? So all these legislative people, or maybe some other people from different fields like psychology, etc., started working on this new reality. Okay. For instance, I'm a member of some group, some artificial intelligence study group, kind of something like that. There are some members. Well, it's kind of new group, let's say, and there are some people. Mostly, they are academic people, actually, but not from the computer science. Of course, there are guys from computer science, computer engineering, but there are also some people from psychology or philosophy or medicine, different fields. People all are interested in these artificial intelligence advances. But you should realize two types, maybe three types of people dealing with this artificial intelligence thing. Um, or we can say that three different dealings with artificial intelligence. One group, one side uh, is somehow related to the use of artificial intelligence tools for their own fields or own areas, right? For instance, take some medical guy or some guy from medicine who is working on producing and developing some new drugs or this kind of stuff. They're just collecting data and analyzing it and everything, and they use artificial intelligence tools for their specific business or area, right? So this is more or less related to the use of artificial intelligence tools, only the use of them. But there are some other people in the computer science and computer engineering areas, basically. They're working on this artificial intelligence area for developing new methods. New methods. On the other hand, since, since we need to understand the mechanisms of thinking or learning and everything, it is not a job only for computer science or computer engineering people, right? Because it pertains into the cognitive science, for instance, cybernetics or all this stuff, right? So these people in computer science, basically, or computer engineering, are somehow related to developing some new methods or approaches, maybe. But there is another, the third dealing, actually, which is somehow involved in uh, adapting our methods, traditional methods, to the existence of artificial intelligence tool. Because the world is not going to be the same, right? Everything should be changed. For instance, take learning in higher education or lower, elementary school type of education, high school or whatever. Teaching or learning should be taken into consideration, and all the methods and things should be re-evaluated, and the goals should be redefined from the beginning, from the scratch. Such an effort requires some people, not only from the computer science or computer engineering businesses or areas, but instead maybe the education or pedagogy or psychology, all those people are somehow related to this field, right? Therefore, artificial intelligence is a real revolution happening nowadays. It started and it's going on uh, by an exponential speed. The advances in this field is absolutely exponential. Next week, I'm going to give a lecture, a seminar actually, to the academic people of Piri University. The title is Artificial Intelligence and Education, or Artificial Intelligence in Education. And during this seminar, uh, I'll tell them the importance of the things, the emergence of artificial, how it will affect our teaching or learning method. And of course, we're going to talk about different applications of artificial intelligence in education. And also we'll have a, a guest speaker along with me. There will be some guy from Microsoft working on the artificial intelligence things. He's the manager. So together with him, I and him will be talking about this stuff that very important title of changing the world and methods and everything. Well, basically in education, but such an adoption is required for the other fields also. Uh, Maybe the production field, factories, or all this stuff should be redesigned from the scratch by the existence or with the existence of uh, robots or such unmanned vehicles, all these different capabilities that we didn't have in the past, right? So, talk about the history of evolution of artificial intelligence, specifically the machine learning. I just underlined the emergence of internet, and through that, the collection of huge amounts of data. The data is the fuel, as I said, for the artificial intelligence. And also the advances in hardware technologies is one of the other keys, because it is the only thing that gives us the opportunity to process such an amount of data. So with that, this field is increasingly getting popularity, and every day a new tool or new method or something uh, appears, right? So when we say machine learning, we should understand the distinction between the traditional automation and machine learning. Okay, in traditional automation, remember the generic sketch we started with you, right? From the beginning, the system approach, right? There are some inputs, and we process those inputs to produce some specific output. You can read that sketch from different perspectives. You may think that, in order for producing such an output, what kind of process is required and what type of data should I collect, right? Let's say if it's a controller of some car or ship or something, uh, managing the speed and the amount of fuel and oxygen and whatever, um, if it is managing it, then what's the need? The need is deciding what data to collect and also uh, the way to process it, right? To produce that output. So we may think of the algorithm itself. I mean, in order for producing that output from these inputs, what kind of processing is required, which is called the algorithm. And then we write algorithms. And of course, we can provide some different cases uh, that can happen during the processing, right? And we handle it using some if-else structures. If this is this and this is that, then do this job or otherwise do that job. So it's a kind of automata kind of business. So we try to automatically do the things. I mean, we have the machines do the things automatically by following the algorithms we provide, right? This is automation in general. By and large, we can uh, enrich them somehow by providing some logic or intellect inside, uh, by only providing different cases. If this happens, do this, or otherwise, if this happens, but that does not happen, or that value is below that value, that data is below that value, don't do this, or instead do that, and this kind of intellect, you see. But this is all automation, and it just follows the steps, including the algorithms, right? But when it comes to machine learning, it's totally different. The approach is totally different. Instead of providing the direct solution, which is the algorithm, step by step, we need to provide the solution, right, for that problem, whatever the problem is. Instead of providing all these steps, we just give the machine, through algorithms, of course, uh, as guidelines. I mean, we provide guidelines to take actions, make decisions and take actions, and then evaluate all these actions, what is the result, and learn and understand whether it is correct or not, and then adapt yourself. Therefore, those algorithms are adaptive. Adaptive. They're not strict as it is in the automation type of applications in computer engineering or software engineering. Instead, they can adapt themselves. Those algorithms can adapt themselves by following the guidelines we provide. All right. So automation and machine learning are two different things. But if you think the use of machine learning or artificial intelligence tools nowadays, it is still at the uh, beginning level, right? Novice level. How? We just try to use artificial intelligence tools in our standard uh, operation automation businesses or traditional works. We have some methods, works, or problems traditionally, and we just try to use the artificial intelligence tools and therefore improve our automation systems, let's say. But this is not it's supposed to be. I mean, it should change. It will change pretty soon. You'll see that the learning methods and production methods, everything, even producing the arts and everything, will change form, right? Change form, and many people from many different areas are required to work on this very, very subject, very reality. Okay. So for understanding machine learning, what is it about? We should see that we in machine learning algorithms get the data as the fuel and deduce the information from data. We just analyze the data and understand its structure. We try to discover the patterns in the data in hand. And if we know the outputs, and also the inputs, we can try to understand the relation between them. I mean, then we can, let's say, develop some kind of logic behind that output. I mean, if this output is produced under these circumstances, under these data, underlying data, from this process, underlying process, then we can discover the reasoning. Why the reason that output is produced from this input, because we process this way or that way. So it can provide us two different things. First, now we can predict the output from the input, right? So we can make predictions and decision making, right? And also we can adjust the processing, the algorithm behind it, because if we are working on that problem based on the output, expect output is strict and defined, predefined, then we may think of the processing method. So we may try to understand the reasoning of the, let's say, the differences between the expected output and real output. Then we should check out the processing methods applied in between, right? So it's a kind of feedback, or let's say in more technical terms, backpropagation type of business. We just backpropagate or feedback the outputs to the input. So our output becomes another input of the processing. So what we produce actually, well, in machine learning, the real output is the model itself. We just produce the model, right? The model. What is that model? As I said, model is the way of solving some problem. So if we do not know exactly how to solve that problem, what is solution, what is the model, then we just try to produce the model itself, the algorithm itself, right? The output of the machine learning, to my understanding, is not the traditional output, but instead the model itself. That makes the machine learn, right? This is the learning part. This is the learning part. By learning, by looking at the input and output data, by learning, it improves the model. All right, guys. I hope that you get a feeling or understanding what is it all about and what is the difference between the traditional automation and machine learning. Okay, let me give a short break and ask you thoughts about all this stuff. Let's switch to Türkçe. Anlama zorluğu olan Pelin'e soralım bakalım. Otomasyonla makine öğrenmesi arasındaki distinction'ı yakalayabildin mi Pelin? Esas olarak nerede?
Evet hocam. Biraz
Yakaladım.
anladım.
Güzel.
Hı hı.
Peki nedir peki? Nasıl tarif edersin?
Yani şimdi nasıl desem bilemedim de kelimelerden biraz anlıyorum. Onu da nasıl cümle olarak söyleyeyim burada bilemedim.
Yani Türkçe sonuçta anladığın şekliyle, yani otomasyonla makine öğrenmesi arasında temel olarak nasıl bir fark varmış? Şimdi zaten arkadaşlar bakın bu oluyor işte. Söylediğim bu. Şimdi anladığınızı biliyorum. Söylediklerimi anladınız. Ama bunu şimdi anlat deyince şeyi fark ediyorsunuz. Nerelerini kaçırmış. Anlatabildim mi? Onun için daha önce de söyledim size sanıyorum. Şöyle bir deyiş vardır. Bir şeyi öğrenmek istiyorsan çalışacaksın. Tamam mı? Çalışacaksın. Öğrenmek istiyorsan onu anlatacaksın. Çalıştın, öğrendin, birilerine anlatacaksın. Yani çalıştın, anladın, birilerine anlatacaksın. Anlattığın zaman nerelerini kaçırdığını, nerelerde eksik kaldığını fark ediyorsun. Peki soruyorum. Bir şeyini öğrenmeyi de geçtin. Ustası olmak istiyorsan ne yapman lazım? Berfin ne diyorsun?
En son dediğinizi kaçırdım hocam, duyamadım da.
Ee, anlamak istiyorsan çalışacaksın. Gerçekten öğreneceksin, ona anlatacaksın dedi. Peki ustası olmak istiyorsan herhangi bir konunun ne yapman lazım?
Ya bence benim fikrimce hocam öğretmek, birini
Ö-
açıklamak.
İşte o ikinci aşama. Üçüncü aşama ustası olmak için ne yapman lazım?
Hiç oraya gelemedim aslında.
Fikri olan bu benim buluşum değil. Söyle nedir? Nedir? Nedir? Bir elini kaldırır gibi yaptı. Sonra vazgeçtin.
Hocam
Take
bence
repetition or maybe use of different sources.
Well, it will help of course, but it is not the way of mastering it. Söyle Öykü.
hocam ben de şey diyecektim. Bence sabırlı olmak lazım. Zaman lazım.
Şöyle diyorlar arkadaşlar. Ustası olmak istiyorsanız onun programını yazacaksın. Bunu sistem analiz dersinde tekrar ele alırız. Çünkü programını yazdığınız zaman bütün akla gelmeyen detayları düşünmek zorunda. Peki, o zaman bir başkası var mı? Otomasyonla makine öğrenmesinin arasındaki temel fark neymiş söyleyebilecek olan?
So I would love to say, if you give me permission,
Of course.
like traditional implementation use predefined rules and logic like if-else sentiments, like set statements, but machine learning, the learning patterns from the data and it makes a prediction on new data. It's not
Okay.
like a traditional.
Okay,
Like
good.
it adapts automatically, like retraining the model with new data.
All right, that's great. Besides, we can say that the real outcome of the machine learning projects, let's say, is the model itself. It always works on the model and the output, produced output, whether it is a prediction or whatever, essentially it will be the prediction, of course. All these predicted outputs will be also inputs of the system. So then we evaluate the outputs and decide about what is wrong or what is the difference, how I can improve it, etc. Then we retune, tune the model itself again and again and again. It goes this way, right? Bilin şimdi biraz daha anlaşılır oldu mu?
Evet hocam.
Ebu Bekir Kambur'a sormuyorum. O zaten anlamıştır baştan sona. Serhat desen öyle, değil mi? Peki, şimdi arkadaşlar saat 11:15. Benim keyfim yerinde, güzel gidiyoruz bence. Konuşmaya devam edelim. Dediğim gibi hepsini kapsayabilir miyiz bilmiyorum. Normalde kaçta bitiyor bu ders? 11:30 mu kaç? 12'de mi bitiyor? Ee,
12.30'da bitecek hocam bu ders.
Şimdi ders programı sanıyorum değişti. Bu ders 9'a alınmış, 12'de bitiyor. Son durumda galiba. Yeniden değiştirmedilerse. Daha önce 9:30, 12:30'tu. Son durumda 9, 11 oldu, 12 olmuş. Derseniz bir
Hocam
kontrol edin.
güncellenmiş hali 12.
Değil mi?
Hı hı.
Ama siz de sistem analizine devam edeceğimiz için dediğim gibi bu dersi biraz uzatıp öbürünü biraz kısaltıp falan konuların gidişatına göre hareket edebiliriz. Bugün şu yukarıda söylediğim 4 tane başlığı e, yani ne derler? Konuşmak istiyorum. Tipleri bilmem neleri. Biraz düşündüğümler uzun sürüyor. O yüzden dersi biraz uzatıp sistem analizinden biraz çalabiliriz. Bir 5 dakika mola verelim gene. Sorusu olan yoksa. Saat 11:16, en geç 11:30'da buradayız. Tamam mı arkadaşlar?
Tamam hocam.
Okay, we're back. You're ready? We can continue. Any questions? All right, no questions. Great. This is one of the books I recommend, okay? And in every book and textbooks available, mostly very expensive, but we can find some ways, all right? Don't worry about it. But in every book, of course, the first chapter is dedicated to the introduction of machine learning and what is it all about. It gives descriptions about machine learning, what is machine learning. People provide different definitions for machine learning, but I hope you get an understanding until now. So machine learning is different from traditional automation software or algorithms. It by looking at the data, it deduces, let's say, gets the information. By looking at the patterns and everything, we talk about different algorithms, how to do it, okay? And reasoning, by discovering the reasoning behind the output, basically. Well, the question is that, what is the reason of this output is produced from these input? What is the processing? Okay, so that means that by looking at the processing, we're focusing on the algorithm inside, the processing algorithm. Therefore, we're trying to develop the model itself. This is why I say that the real outcome, not output, but outcome of a machine learning system, say, is the model itself. Okay, so based on these models, we just produce some predictions, which means, as you know, from the data analytics course, from descriptive analytics, you know that by looking at the data, the inputs, we just put those inputs in place, apply the model, and then produce some output, which is the prediction, right? We predict some specific output. Of course, while doing this, we use some computational methods to learn, okay, to learn this information directly from data itself, without relying on some predetermined equation or formula, etc. Okay. But here there is another thing, another feature, which makes it learning algorithm. It is the adaptation abilities, right? It adapts itself. It adapts the algorithm, the model itself. Okay. By looking at the performance, well, how we can define the performance here, or how we can measure it? Well, of course, we can measure it by looking at the prediction we produced and the real expectation, right? The difference. We just check the difference and decide about the level of error, let's say, and that provides us hints about learning, right? Actually, learning occurs for humans or for any living thing the same way, right? by doing things and by looking at, by looking at the results of the actions we take, we just decide whether it is good or bad, or the level of goodness or badness, right? And then we learn through these paths, let's say. Okay. Of course, this adaption capability improves, which is the performance, improves by the amount of data, which is the learning examples, right? So we just look at the examples. These are the observations or instances, and it helps us detecting the patterns inside, right? So this area, machine learning area, is in the intersection of statistics and computer science, basically, of course, mathematics and all other stuff. But it resides in the artificial intelligence ecosystem, as I mentioned earlier, right? At first, it appeared as rule-based, we call it rule-based systems, which is kind of if-else structures. As I said, that we provide some cases. If this is this and this is that, in that case, do this. So these describes all these if-else structures or such structures are named as kind of rules, right? But traditionally, especially in the past, these type of rules are described not using these if-else structures as we are accustomed to in Python or C language or this kind of third generation languages, but some other specific languages are used for this purpose, especially for artificial intelligence type of programming, like Lisp language or Prolog language. So they have some other syntax or other keywords, but the basic thing, the basic idea is the same. I mean, if this is this and this is that, this describes a rule. So we just provide a rule base to that system, that rule-based system, which are called actually the expert systems. Okay? And also we provide some knowledge base. Well, it is something like, let's say that if it has some wings and if it can fly, then it is a bird. This kind of rules, okay? Some rules or conditions, and also we can say that canary is a bird or eagle is a bird. So then we can deduce from this knowledge, applying these rules, that, for instance, what is that creature? Well, it has wings and it can fly, then we can say that it's a bird. But when we encountered with, let's say, dodo bird, dodo is a different bird, which cannot fly. It has wings and everything, but it cannot fly. But we still name it as a bird or categorize it as a bird. Then it's another new knowledge. So from this knowledge, we can develop new rules, right? That makes the system learning system, okay? This is the learning part. So we can develop some new rules. Okay, it may have wings and also the other features of a traditional bird, but it cannot fly. But we still can name it as a bird or categorize it as a bird. So we just produce new rules. Those rules were not provided at the beginning, but we produced it. And of course, we need to describe the method, which is the algorithm of deducing or developing a new rule. In what ways, or what are the guidelines to produce a rule, new rule? Okay, goes this way. Of course, these expert systems, rule-based systems, are heavily based on probability theory and everything. Okay, and mycin, for instance, it is used in medical experience, internal medical diseases. It is used. It's called mycin. It is one of the very first applications, implementation, or expert systems in the past. Well, when we were in masters in USA in 80s, they were teaching these rule-based artificial intelligence systems in the artificial intelligence course, okay? Machine learning term was not created yet. Later on, it changed form. Here in this rule-based systems, we develop algorithms, but these algorithms are specific for some specific jobs. I mean, we just pick up some particular business. I mean, let's say consulting the doctors to decide about the disease of patients, etc. So what is data? Data is the blood pressure or this kind of stuff, you know. We provide this data. And by looking at this data and using that knowledge base and the rules and everything, it says that it is at that percent this disease or that disease or this kind of stuff. But these are all algorithm, let's say target specific. These algorithms are specific. So this is the limitation of these systems, right? But instead, we do not give any extra information knowledge for some purpose. Instead, we just teach it how to learn and let it go and understand what happens. It becomes a machine learning project or machine learning system. How it occurred, well, when I was in the masters, as I said, that there were some very pioneering systems like my scenario, but these are all rule-based systems, but the data available was very limited, okay? And of course, that data is specific to the area, maybe medical area or whatever. But later on, as I said, the data is larger and larger, so researchers also made some progresses in understanding the mechanisms of reasoning and learning and what is reasoning, what is learning. So it also pertains into the cognitive science or this type of other areas. So by looking at these methods and observations, they generalized the algorithms, they generalized the reasoning models and everything. New methods are derived from this. Therefore, all this stuff, all these efforts evolved towards machine learning, which is the learning algorithms, actually. Think about that. For instance, face recognition, which is very common nowadays, was not possible, right, until 2001, right? First successful, let's say, successful face recognition software or algorithms were developed in this date. So it was not very early. I mean, it was pretty new, actually. And in such a job, recognizing some face or something, we may follow different approaches. For instance, in the past, we just try to describe what a face is, and we just compare the patterns we recognize, whether it's a circle or whatever you see, and what are the similarities between a face and this image or figure. So it's heavily based on the pattern recognition, but then some other methods were derived or developed, like checking the pixel values, regional pixel values, actually. We just divide the figure or image in hand into some sub regions and check the pixels in these regions. And for every instance, we compare the results, and through such a way, through such an algorithm, we decide whether it is a bird or cat or dog or this kind of. So these approaches are totally different. All right. So is not a rule-based system. Instead, it's a system that it can learn by itself by looking at the outputs and inputs. It just improves the method learning or the decision method, let's say, prediction. Okay. So from this, I believe that you get an idea of what machine learning is. But if you go into any textbook, it describes you what machine learning is. It gives some extra information. Read them, okay? Read them. And also this book is another one. Every machine learning or artificial intelligence book necessarily give you some definition of machine learning. What is it all about? So let's talk about the types of machine learning. Actually, there, at least for today, there are three types of machine learning methods. One is the supervised learning. What is it? If the outputs are known in advance, then we apply supervised learning. If the outputs are not known, we apply unsupervised learning, and also some other methods, basically called reinforcement learning, and some deep learning, semi-supervised learning, different types of machine learning approaches we can talk about, batch learning, online learning, etc. Self-learning, for instance, self-supervised learning, for instance, another thing, self-supervised. Actually, the definitions and categorization in this field is also evolving. And during this course, this semester, we cannot cover all of them. We're going to talk about supervised learning, of course, and unsupervised learning. But unfortunately, we probably wouldn't have any time or opportunity to get into the reinforcement learning or deep learning or this type of learning method. But I'll try to provide you some information about what, let's say, reinforcement learning is, as far as I can. I'll mention all these others as far as I can, and then leave it to your curiosity and effort. Okay? Anlatamadıklarımı sizin merakınıza ve öğrenme gayretinize bırakacağım. Zaten it is impossible to follow all the new evolutions or developments in this field. Every day, as I said, that a new tool appears, a new approach emerges. So whatever you teach or work or learn today gets old maybe next year. Some new method, some new techniques appear. So then I and everybody actually choose the most important, the principal categories of this machine learning method, supervised and unsupervised, and also we may talk about a bit about this reinforcement learning. Okay, so these are the types. So let me give you a few insight and details. What are the distinctions between these? As I say here, if the outputs are known or not known, that provides a kind of distinction. But let's take them one by one and talk about supervised learning first. And here, we know the outputs, right? The outputs are labeled. That means that this is this and this is that. Like this one, for instance. If you're talking about email, we may know that whether this email is a spam or not. Okay, so we just label it spam or not spam. Or let's say if it's a medical project, like to determine whether this tumor is malicious or not, we know the output in advance. Okay. So what are the inputs? For instance, here, the inputs are the texts, email messages, right? And we also know the output, labeled output. That means that this text, this input, is spam, but this one is not, this one is not, this one spam. So by looking at the inputs and output, we create the model, the model in between. What model we're talking about? The decision model, of course. Okay, and also for this one. So here we apply the supervised learning method, since we know the outputs in advance, or let's say that credit card fraud detection type of implemented applications. Also, we have transactions, okay, bank transactions, etc. And also we have some data about fraud transactions. So by looking at them, we just create some kind of model which helps us predict the output, whether it is a spam or malicious tumor or fraud transaction or whatever, right? Therefore, we call it supervised learning. And by looking at the examples, which is the sample space, okay, we just tune the algorithm. Okay. Here, the labels may be discrete or continuous. All right, guys. I believe that you understand what I mean when I say discrete or continuous or categorical, etc., right, from the data analytics course. So if these are discrete inputs or labels, actually, this is a classification type of machine learning algorithm, classification. So we classify whether it's a spam or tumor or fraud or whatever, okay? But if it's continuous, mostly numeric, normally numeric, or even if it is not numeric, we just convert into numeric, right? Then we apply regression techniques. This is why last semester I told you all about these regression methods or classification methods. Okay. So here in this classification type of projects, like spam, not spam, it may be bidirectional or two possibilities, or maybe more than two possibilities. Like, let's say that if you're trying to identify the handwritten letters, okay, and convert into digital, is it B or C or whatever, then there will be many different but discrete outputs, right? Discrete. It is either E or B or C or whatever, A, B, C, but nothing in between. So it is not continuous. Instead, it is discrete again, discrete. But here, it is not only two categories, spam or not spam, but instead, it may be multi-categorical, okay? Multi-categorical. But in this prediction type of systems or projects, you'll remember that there will be some dependent variable which we try to predict, okay? Like a student success type of project, the dependent variable may be the success of the student, which is the grade, exam grade, something like that, right? So this is the grading dependent variable. So for predicting the exam grade, we may check what this exam grade or success grade depends on, or what is it related to, which features or which data. So there will be some independent data, like as I gave you in the last semester. It may be the distance from the school, or working hours, or age, or gender, or many different data we may have in hand. So by looking at them, we just try to develop a regression model, and that regression model helps us make some predictions about the outcome. So again, we just try to predict the dependent variable based on the independent variables. But of course, we since we know the dependent variable, the output in advance, we just train our model. We just give the data in such a way that this is girl and she lives at that distance from the school and she spares that many hours to studying this course or whatever, and her family deals with whatever, her income, blah blah, all these inputs, and also the output. We just label it. I mean, we just provide the exam grade of that student, okay, and the other all these students, and after providing all these dependent and independent variables, by applying the data analytics method, we develop the model, and that regression model will be used later for the unknown samples. Therefore, we can say that by using the known samples, known output, we train our model, generate our model and train that model, and then we apply this model for unknown samples. Okay? Any questions about it? Herkes anladı mı söylediklerimi? Anlamayan, kaçıran, şurasını kaçırdım diyen? Harikasınız. Çok iyi. Great. Okay, let's continue then. Therefore, guys, I again highlight the relation between the correlation analysis and regression analysis. They are highly related. And again, I advise you to go back to data analytics notes and check these titles: regression, correlation, all right? Model construction, what is a regression model, etc. We're going to talk about them in this course also, but from a different perspective, machine learning perspective, and with some extra details, okay? And also, as you know, that it can be linear or non-linear. And for this supervised learning, we have many different algorithms, and we're going to talk about them one by one. For instance, k-nearest neighbor algorithm. We covered that algorithm a few times, right? We told about it in data structures and algorithms course. Remember that k-nearest neighbor algorithm? I mentioned and described it. All right. And also it is used as a tool in machine learning. Okay. Also linear regression. We covered it last semester. We're going to use it. There are some others called logistic regression or support vector machines. All right. Or naive Bayes. We are going to talk about them, all of them, this semester. Random forest decision trees, and also neural networks. But some of these algorithms, mainly based on the predictive statistical modeling. Okay, some of the algorithms are heavily based on predictive statistical modeling, like k-nearest neighbor or regression. But some of them are adaptive learning algorithms, support vector machines. We're going to talk about them one by one during this semester. Okay, and believe me, every one of them takes 1 week's lecture. For instance, they'll take logistic regression, describe it, how it works, etc., and then try to give an example. And next week we'll go into this and that. It goes this way. Therefore, this is why we cannot have to cover all the topics involved or residing in the machine learning. But instead, at least you need to understand the supervised and unsupervised learning depth at a sufficient level. All right, guys. Any questions about supervised learning?
So is it like I understand the goal is for this model to learn relationship between maybe inputs and outputs, and after that it's predict the correct maybe output for the new data, right?
Absolutely.
Okay.
Absolutely. By looking at the input and output, since we know the output in advance, as we say that the outputs are labeled somehow, as this email is spam, and we provide also the input, the text itself, we just create the correlate. I mean, we apply the correlation analysis and regression analysis, all this stuff, and come up with some specific model. All right, specific model, and that model is tested after training. Is tested on the sample data also, which is the outputs are also known in advance, the labels. So the sample data is divided into two parts actually, mostly 80% to 20%. We use the 80% of the data, sample data, for training the model, creating and training the model. And then we test the model based on the remaining 20% and tune, modify the model, and then start using it. Okay?
Okay,
So
sir.
this model is used to predict the unknown samples.
And
That's
it's
actually
already trained on the labeled data. They're already ready, like I understand.
yes, yes.
Okay.
After training, the model is constructed and we just apply it. Okay?
Okay.
Apply it to who? To, let's say, a newcomer, new student. And by checking the inputs, applying the model, we predict the success of this student. Okay?
Okay, sir.
All right. So this is supervised learning. But as I said, if we do not know the labels, even nothing about the data, the internal patterns, everything, we apply unsupervised learning. Here, inputs are known, of course, but outputs are not unknown. We apply different methods, like, well, we may need to group the customers and the input data, maybe the purchasing habits, and also the other things. I mean, again, gender and salary or whatever. I don't know, the raise or whatever. So by checking or working on analyzing the data, we just try to come up with some certain patterns, whether these inputs imply some internal groupings. As you would remember, for this, we use that clustering method, for instance. So the data is not labeled, but through clustering, we divide it into categories, cluster them, and that means that we just label them, right? So we just say that this group of people are, let's say, some, let's say, book readers or whatever. Or this group of the people are buying some sports goods, shoes or t-shirt, shirts, or this type of sporting goods or whatever, right? So we just try to cluster them by looking at the data, only the data itself. And last semester also we covered that clustering thing, clustering method. And this semester in this course, we'll get into this clustering again one more time, and we will use it in machine learning projects. Okay, so it will be a kind of repetition for both the regression and also clustering. It will be a kind of repetition for you. We'll cover the same things again this semester. Again, we're going to talk about the K-means algorithm or FC-means algorithm, all this stuff, hierarchical clustering algorithms. But this time, since you know what clustering is, you'll start using them in machine learning projects, okay? This is the idea. Mesela mühendislikte arkadaşlar, oradaki arkadaş, data analitiği ile ilgili işte ders veren arkadaş, mesela clustering'i filan data analitiğinde anlatmamış. Ya siz onu niye nasıl anlatıyorsunuz falan filan diyor. Halbuki ben şöyle düşünüyorum. Clustering'i bileceksiniz ki bağımsız olarak nedir ne değildir. Onu machine learning içinde kullanabilelim biz. Hiç anlatmazsa önce clustering'i anlayacağız ya da önce regression'ı anlayacağız. Ondan sonra bunu makine öğrenmesinde kullanmaya başlayacağız. Ben öyle bir yolu izlemiyorum, tercih etmiyorum. Onun yerine siz geçen dönem hem regression'ı hem clustering'i öğrendiniz. Dolayısıyla onları kullanacağız. Also, there is another technique called principal component analysis. But actually, it is used for dimension reduction type of things also here. But the purpose is different. Here, by applying this principal component analysis, we try to figure out the most important or principal features affecting the result. Okay, so it's a kind of feature detection business. If you figure out the features, the principal features, that means that you are deciding about the main factors, the principal factors affecting the output mostly, heavily, okay? The weight of the effect or the significant or principal features in the data. So after applying this, you may omit some of the features. Instead, you may consider or focus on some specific features and work on it, okay? So principal component analysis is another thing. We're going to cover it also during the semester. Okay, guys? And also, lastly, we can talk about reinforcement learning. Well, actually, I don't know, again, whether we're going to have extra time for covering all these or applying some projects or whatever. But the idea is different from the previous ones. We just observe the environment, and based on the environment, which is the input all around, it can be anything, we just make decisions, okay? This is this and this is that. And based on these decisions, we just take actions, apply these decisions, okay? And then we evaluate the result. After this action, some result occurs, some output, and we evaluate that result, okay? And depending on that result, we just give a reward, which is good, okay? If the result is as we expected, we give some reward. Of course, only true, false, or bad, good, not this type, but we may also degrade the rewards, or we can produce some penalty for this. And based on this reward and penalty, we just update the policy. If we are getting reward, then we update the let's say the policy behind the decision we made here. We update the policy, which is the learning stage actually, and we iterate this again and again and again. Every time these rewards and penalties change. So based on this, at the end, we reach some optimal solution or optimal model, reasoning model. Okay. So this approach is totally different from the other ones. And the novelty behind this approach is the reward penalty mechanism application. Well, here, for instance, chess bots or Go game bots. This type of game bots mostly are based on this reinforcement learning. Okay. There may be many different actions to take, and we decide about one of them based on some specific things or guidelines. Or maybe there is no guideline. We just randomly choose some action at the beginning, okay? And then check the result. If it is reward, we change it and change it. Or if it is penalty, change it, okay? Until we reach and decide about the optimal policy or optimal actions. Okay? And 2010, in 2010, some Go bot, what was it? AlphaGo, in AlphaGo, that bot, that machine learning project, beat the world champion, Go world champion. Go oyununu biliyor musunuz arkadaşlar? Bayağı gıcık bir oyun. Yani aslında kuralları çok basit ama dünyanın en zor oyunlarından biri. En stratejik, satrançtan falan daha ağır olduğu söyleniyor. Yani ben de biliyorum kurallarını oynadım ama yani o detayda incelemedim neden daha enteresan satranca göre neden. O konuda da yanılmıyorsam bir Japon dünya şampiyonu. Herif neredeyse rakipsiz yani yanına yaklaşılamıyor. Yarattıkları bir şey 2010'da ki 14-15 sene geçmiş üstünden yani. Yendi. Herifi 4-5 oyun sonra yendi. That AlphaGo ki siz buna mesela internetten girip şuradan AlphaGo diyelim. Eminim AlphaGo. Evet. Bakın Google'ın DeepMind projesi çerçevesinde falan. Hani bunları inceleyebilirsiniz. Computer Program, DeepMind Technologies, etc. Hatta bununla ilgili yani bu AlphaGo projesiyle ilgili o şeye haber veriyorlar o şampiyona. Bilen o şampiyonun anılarını anlattığı, nasıl gerçekleşmiş olay, o nasıl düşünmüş, nasıl yaklaşmış falan, nasıl hafife almış, sonra nasıl şaşırmış, onlara anlattığı da bir video izlemiştim. Siz de bakabilirsiniz. Okay. So this is reinforcement learning. Okay, it's 12:12 now. Let me complete and finish.
So can I give an example for reinforcement learning?
This is the example, chessbot, AlphaGo or Deep Blue. These are all machine learning programs based on reinforcement learning. They work on reinforcement learning algorithm or approach. Okay?
And maybe self-driving cars, like when they trail and
it may change. I mean,
yeah.
you can develop some self-driving car based on reinforcement learning or some other methods. Okay.
Yes.
As I said, that there are many different self-supervised methods or semi-supervised. There are many different methods. Bakın bu alan aslında oldukça emekleme döneminde hala. Ve şimdi oralara girmiyoruz. Biz mevcut olanları anlamaya çalışıyoruz. Bu alanda yaşanan tıkanıklıklar ve sıkıntılar var şu an. Tamam mı? Bir kısım insanda o konularda çalışıyor. Yani nasıl yeni bir yaklaşım bulma peşinde insanlar. Mesela bu bir yaklaşım. Böyle öğrensin. Öbürü başka bir yaklaşım geliştirir. Anlatabildim mi? Dolayısıyla yeni yaklaşımlar, dolayısıyla onlara uyguladıkları yeni algoritmalar ortaya çıkıyor ve bu algoritmalara bağlı olarak da çeşitli uygulamalar çıkıyor. Siz bugün diyelim reinforcement learning'e dayalı çalışan bir self-driving car veya işte otonom insansız deniz aracı bilmem hava aracı neyse üretirsiniz. Yarın başka bir yaklaşım çıkar. Başka bir metoda dayanmaya çalışacaklar. Tamam mı? Bizim derdimiz bunların temelde ne olduğunu, mevzunun nasıl işlediğini, her bir algoritmanın kendi iç mekanizmalarını falan bunları anlayıp bunları uygulamak. Tamam mı arkadaşlar? Biz zaten emin olun bu derse bugün başladık. Dönem sonuna geldiğimizde burada bunları konuşurken olmayan yeni şeyler çıktığını göreceğiz. Yani müthiş bir hızla ilerliyor yani.
Ben bir haber okumuştum hocam. Bu Tesla kendi araçlarını eğitirken mesela test aşamasında önüne engeller çıkarıyor veya cezalar kesiyor. O kendi kendine sürekli en iyi sürüş deneyimi sağlamak için o algoritma sayesinde hani
Evet,
en
evet.
güvenli şeyi sağlıyormuş.
Evet. İşte mesela bu reinforcement learning'in örneklerinden biri. Tabii bakın bunlar bu cezalar, rewardlar filan bunları yine her zaman söylediğim gibi objektif olarak tarif edeceksiniz. Değil mi? Ne olursa ceza yani kötü ne olursa iyi bunu tarif etmeniz lazım. Ve onu sayısallaştırmanız lazım. Yani size hep ısrarla hani üstünde durmamın nedeni budur. Hani bugün hava nasıl? Güzel. Yok. Mühendislikte öyle şey olmaz dedim değil mi size? Bugün hava şu kadar derece bilmem ne. Dolayısıyla iyi, kötü diyorsanız bunu tarif edeceksiniz. Sübjektif bir şey değildir. Onun objektif ölçütlerini ve miktarını söyleyebilmeniz lazım. Bunlara gelince reinforcement learning'e falan eğer vaktimiz kalırsa buna da gireriz. Orada biraz daha ayrıntılandırmaya çalışırız. Dediğim gibi arkadaşlar ben bilgim çerçevesinde size değinmediğimiz konuları da belli ölçüde en azından nedir ne değildir gibi bahsetmeye çalışacağım. Ama e, yani hepsini her şeyi anlatmak mümkün değil. E, Dolayısıyla ardımızda bıraktıklarımız veya dediğim gibi bugün yok, yarın ortaya çıkacak yeni şeylerin öğrenilmesini sizin merakınıza, öğrenme e, iştahınıza ve gayretinize bırakıyor. Benim yapabileceklerim sınırlı. Onun için de elimden geleni yaparım ama gerisi sizin işinizdir. Her birimiz için bu böyle. Ve açık söyleyeyim yani ben şimdi size reinforcement learning anlatıyorum. Hatırlatırım arkadaşlar ben master'ı, doktorayı bilmem ne bitireli yıllar olmuş. Bunların hiçbiri yoktu ki. Ben şimdi bunları size anlatıyorsam ben öğrendim. Kimse bana anlatmadı. Okay. Yani bu işte ne bileyim fizik dersi bilmem matematik dersi gibi değil. Computer veya software engineering'de bir konular sürekli geliştiği, değiştiği için yani ne bileyim ben işte Taylor serileri bilmem ne zaman 1800 bilmem kaçta tamam bunu adam öğrenmiş anlatıyor size. Değil mi? Yani o alanlardaki gelişmeler en azından lise, üniversite seviyesinde anlatılan konular 1800'lerde, 1600'lerde, 1900'ler ne bileyim bilmem ne zaman bulunmuş ve şimdi öğretiliyor. Ama bizim alanımız software engineering genel olarak öyle bir alan değil. Dolayısıyla anlattığım birçok şey ben öğrenciyken yoktu. Bunları ben kendim öğrendim. Ama dikkatinizi çekerim. Dolayısıyla da sizin de aynı şeyi yapmanız lazım. Tamam mı? Yani isterseniz dersi burada keseyim. Yeterince kafamız şişti. Daha e, öbür derse geçeceğiz. Epeyce de bir şey var konuşamadığımız. Bir dahaki hafta kaldığımız yerden e, devam ederiz. E, Dolayısıyla şöyle yapalım. Paylaşımı durduralım. Bunları bir slide haline falan getiririm vaktim olursa. Size de veririm. Olabildiğince not tutun. Kitaplardan yararlanmaya çalışın. Bu videoları da izlersiniz. Gördüğünüz gibi 2 satır yazıyoruz. Üzerinde 2 saat konuşuyoruz. O yüzden sadece slaytlarla bir şey öğrenmeniz mümkün değil. Not tutmanızı tavsiye ederim kitaplardan yararlanın. Ee, evet, ne diyordum? Dediğim gibi yani bu konular sürekli gelişiyor. yeni şeyler çıkıyor. Bunları siz öğreneceksiniz. Öğrenmenin yolu da uygulamaktır. Önce anlayacaksınız. Bunun için araştıracaksınız, bulacaksınız. Yani bu öğrenme süreci bitmeyen bir süreçtir. Ömür boyu devam eder. Tamam, ben öğrendim, oldum, artık onu uygulayayım. Belki hiçbir alanda yoktur böyle bir şey. Yani ne bileyim ben, çiçek yetiştiriyor olsanız orada da benzer bir şey var. Mobilyacı olun, elektrikçi olun. Yani tamam, öğrendim, artık elektrikçiyim, diplomamı da aldım. Ömür boyu elektrikçiyim. O alanda da yoktur. Orada da gelişmeler olur falan filan. Kaldı ki bilgisayar alanında, özellikle bilgisayarın yazılım alanında böyle bir şey mümkün değil. O yüzden yani benim kıymetimi bilin. Ne anlamda söylüyorum? Benim derdim size bir şeyleri öğretmek değil. Ne dedim? Öğrenmeyi öğret. Tamam mı? Öğrenmeyi öğrenirseniz bir yere varırsınız. Öbür türlü sadece benim anlattıklarımı öğrenirsiniz olduğu kadar. Ama orada kalırsınız. Yani öğrenme sürecine yaklaşımınızı ona göre belirleyin. Tamam arkadaşlar.